Welcome everyone. I'm going to get started. So thank you so much for attending today's webinar on implicit modeling with Altair Inspire. As I kind of go through a couple intro slides, I'm kicking off a poll here. So feel free to kind of go through that poll and let me know if, you know, your thoughts and questions as you go through that. So like I said, my name's Drew Buchanan. I'm the engineering manager here at TrueInsight. TrueInsight is a channel partner with Altair. So if you're unfamiliar with Altair, Altair's vision really is to help engineers, designers to leverage simulation, HPC, and AI to make better decisions as you guys are going through the design process. One of the things I want to point out, we're talking about implicit modeling today, specifically, get into a little bit of simulation, but if you have some type of problem, we most likely have some type of solution there. And we run the gamut from physics-based simulation and CAD modeling like we're going to be working through today in today's webinar, to data analytics or IoT. Feel free to, if you have questions about something pertaining to any other solutions, feel free to put them in the chat. My colleague is monitoring the chat right now. Also, always happy to chat with people after the call as well. The other thing, just to point out, if you're on Altair as a company, our tools have been used by various customers. And I think the really cool thing you guys are going to see as we work our way through today's webinar in implicit modeling, the applications kind of run the gamut from, product design through aerospace and automotive, through, government and defense. There's a lot of customers that are using dfam and additive manufacturing, and being able to take advantage of implicit modeling is super, super useful. So with that being said, what's going to be our agenda as we work through today's webinar? First, I'll give kind of a primer on implicit modeling, if you're unfamiliar with what it is. If you see the image on the right, it's the idea of being able to generate kind of highly complex structures like lattices, but it's not limited to lattices. It's based on the mathematical framework versus traditional CAD modeling. And I'll step through what that is in the next few slides. Then we're actually going to spend some time within Inspire 2023, focusing in on implicit modeling. So we'll jump through the different types of lattices, specifically looking at field-driven design, and even jump into a little bit of Python scripting. Like I said, if you have any questions as I'm going through this, feel free to put them in the chat. I'm going to save most of the questions for the end of the webinar, so we'll have some time at the end. I'll respond to questions, but if you have something you want to ask as I'm going through it, feel free to put it in the chat and my colleague will attend to it. And if he doesn't attend to it, I will take a look at it at the end of today's webinar. So great, what exactly is implicit modeling? So really the idea of implicit modeling is defining a surface or boundary of an object through mathematical functions. So most of you probably are familiar with explicit modeling, which would be kind of traditional CAD, SolidWorks, PTC, et cetera. You're explicitly modeling a coordinate in space. And as you can imagine, as you start having more and more complexity, like say lattices, gears, anything of that nature, it becomes very, very complicated. The advantage of implicit modeling is you kind of see through this. It looks at the actual boundaries of your system and creates an isosurface. And that isosurface is how you actually model the 3D fields for implicit modeling. So you kind of see that one image looks like a bunch of numbers. That's representing the positive and the negatives, and that's how it's able to map. So as a result of its capabilities of being able to model things through mathematical functions, it's much more computationally efficient than, say, traditional explicit modeling. So it really allows you to kind of work on complex geometry. The advantage of additive manufacturing is we can now, easily manufacture lattice structures, and lattice structures are super, super handy. We see them in nature, in bones and biology, and being able to utilize that technology and be able to model it is very important. So why do we want to use implicit modeling? So like I said, with implicit modeling, you're modeling one sort of single isosurface, which kind of eliminates the need to kind of create NURBS surfaces. A lot of you probably have done some surface stitching. That's I did it in one of my previous jobs. It can be very painful going through surface modeling and having to stitch things. Sometimes it works. Other times it can be very exhaustive, both computationally, but also kind of frustrating. And because in implicit modeling, you're modeling a single ISO surface, it automatically kind of generates those interfaces, which is very nice. As a result of this, you can really model really complex topologies. We'll actually take a look at some with the different types of lattices and complicated structures we can create. And trying to do this in traditional explicit modeling, like traditional CAD, can be very complicated. So one of the things specifically, if you kind of look at the images on the right here, it's kind of an example of implicit versus explicit. You kind of see those fans and kind of a heat sink with some lattice work in it. If you're trying to model that in traditional CAD, since it's 64 by 64 by 64 kind of lattice, that means there's about 260,000 unit cells. To try to do that in explicit CAD would be about 25 million NURB surfaces. So it would be very, very complicated and very computationally exhaustive. This was all done in Inspire. It was very, very efficiently done. That's one of the huge advantages. The other thing that's nice about implicit modeling, because you're kind of looking at things through mathematical functions. And again, this is done in the background. You'll see in the GUI how easy it is to model this. It allows a lot of spatial geometry control, meaning say I want to adjust this lattice density as I move through the system in the X, Y, and Z directions. Maybe I want to combine lattices. It can allow you to do that. The final thing about it is it's really set up for automated workflows, really easy to script if you want to. With the Inspire interface, you can do everything within the GUI, but we do enable Python scripting, so that makes it very nice. So with that being said, let's jump into this. Okay, so here's an example of traditional lattice design in traditional CAD. So this would be explicit modeling, like I kind of mentioned, some traditional, tools out there, kind of B-rep geometry, how you would go about approaching a lattice is you would generate a unit cell. And the process of doing that typically is creating surfaces like you see on the left-hand image right here. You generate them and you form a unit cell in the middle. From that point, you then kind of pattern it and you do it in whatever 1, 2, or 3 dimensions. This can be done in explicit CAD, but it becomes very computationally exhaustive. You start having very huge files, and it also takes a while to render or move things around within the system. Whereas in implicit modeling, you are modeling everything through a single ISO surface. So again, it's able to kind of model all those values very efficiently. So some of the advantages of using implicit modeling. So we talked about being able just to model lattices efficiently. That's a huge game changer and kind of the time savings there. But also in traditional explicit CAD, you are kind of limited in what you can do. Specifically, you kind of have to pattern a unit cell, and that makes it very hard to kind of do like translational adjustments. So you see this image on the left-hand side here under translation adjustment. This would be an application where you kind of see where in the the Y directions, the number of cells, those little holes start to kind of change. So you can actually adjust your lattice work in the Y, Z, or X directions. It's very challenging to do this in explicit modeling, and it cannot be done really efficiently. You can do it, but it's not really efficient, and that's something you can do very quickly in implicit modeling. The other thing would be density adjustment. Density adjustment allows you to kind of make some things thinner and thick. So thinking about why would you potentially utilize lattices? One would be kind of strength to weight savings. You're reducing the whole mass you need because you can manufacture it with additive. And sometimes you may want to have a thicker lattice for something that's maybe carrying more of the load. And then other areas of your part may have just less lattice. It might be an aesthetic thing, but that's kind of one of the cool things about implicit modeling. It makes it very easy to adjust density. You can see right here on the left-hand side, it's much more dense in terms of solid material. It works its way to the right, and it's less dense. And this can be easily modeled in our tools and specifically Inspire. The last thing that's really nice about this is you have capabilities to combine multiple different types of lattices. This gives you kind of capabilities for, like an example would be like a heat exchanger, trying to have a really kind of nice optimized system with multiple kind of flow patches to move through, and being able to combine lattices is something that's really, really nice within our tool. So within our tool in the most recent release of Inspire 2023, it brought in implicit modeling. Altair has a tool called Solus, which was a implicit modeler, but most of those features have been migrated over to Inspire, and it really makes the interface very nice and efficient. So what we can do in Inspire now is we can actually create this implicit geometry. And I'm going to step us through a number of examples kind of going through this. But one of the things I'll say is just this is how the menu is kind of laid out. So those of you who are familiar with Inspire, the great thing about this is it's built directly into the Inspire tool, and it has the kind of same GUI and interface you'd expect for kind of our traditional BREP modeling in Inspire. We can now do it for implicit modeling. So you kind of see on the left-hand side here under the create option, you'll see a number of icons. Starting from the left with the primitives icon, it gives you capabilities of being able to have automated tools, which would be cuboids, cylinders, and spheres. And then specifically, it allows you to kind of automate the actual process of applying those parts. One of the nice things about the primitive tool is say you have you're importing a whole geometry into the environment, and maybe you want to have kind of a small kind of location with some lattice work. You can apply it accordingly, which is nice. Then we have our kind of three lattice options, which would be surface, planar, and strut. And keep in mind, stochastic latticing will be kind of released in the next release. So that's kind of in development, but that'll be there. But surface, planar, and strut lattices, a surface lattice is really kind of tiling or patterning a base unit cell, and it's repeating those over the actual ISO surfaces, and it really creates a lattice structure automatically. So if you're familiar with kind of complex lattice geometry, this would be like a TPMS, which would be like a gyroid lattice, and I'll step you through a number of those lattices on the surface side. A planar lattice, as the icon kind of sees, you have a 2D cross section, then you extrude it. So gives you some lattice work from kind of a constant extrusion perspective. And then the strut lattice, that's kind of what you saw in the previous slides, where you create a unit cell and then you pattern it in 1, 2, or 3 directions. And between the unit cells, the nodes are connected by beams. The other two options you see right here would be the point cloud and the field data. The point cloud and the field data are specifically nice because they allow you to adjust geometry properties or have kind of variations in, say lattice density. I'm going to show you an example where you can actually vary the lattice density with respect to a field, which could be a point in space, it could be the planes, but it gives you that capability. The other thing is a lot of you have done some like additive work or familiar with point cloud data. We can also take advantage of point clouds in terms of how we're kind of creating our lattices. So there's a lot of kind of custom creation built into the environment. The other thing that's really nice about the implicit modeling tools in Inspire is we have a number of tools to kind of work with BREP geometry. This would be kind of traditional CAD model geometry. And you kind of see a lot of these commands look very familiar if you've done any work in Inspire previously to 2023. You see the Boolean operations, but these Boolean operations are for the implicit geometry. So it makes it fairly easy to combine, subtract, and intersect. I think that's one of the things that's really nice if you're coming from a kind of a traditional kind of explicit CAD modeling background. A lot of the modification features in Inspire are very similar to what you may be familiar with. Same thing with an offset. It kind of offsets the top and bottom surface. It gives you capabilities to specifically shell the system. One of the kind of the 3 final features you see right here would be morphing, smoothing, and filleting. These really allow you to kind of combine bodies into multiple components. The other thing that's really nice about the smoothing component is ultimately a lot of you are going to probably utilize implicit modeling, are going to probably send these to be printed. Within the Inspire framework, we actually take advantage of most printing formats. One of the key ones being 3MF. And with 3MF, it gives you capabilities to have a fairly nice capability in that regard of being able to export. But the thing that's nice about smoothing is it gives you the capabilities to remove kind of unwanted pieces or sharp features in an implicit body. So that's something that's fairly nice in that regard. If we look at the fillet option right here, it allows you to round edges of implicit bodies to constant radius. and that really allows you to kind of adjust things accordingly as well. Okay, so let's jump into some demonstrations of lattice work within Inspire. All right, so you'll see within the first thing, if you're unfamiliar with our tools, I just want to make it kind of clear in terms of importing, you can bring in pretty much all kind of traditional explicit CAD geometry, pretty much all native formats and neutral file formats. So that's probably going to be the common workflow you can utilize. But keep in mind, Inspire has always been kind of a traditional BREP tool. So if you actually wanted to actually create geometry in Inspire and then actually jump to implicit model, you could do that as well. In this case, we're going to start from an actual kind of pre-built bracket. And you'll kind of see I actually did generate this in Inspire. So that's kind of one of the cool things about the environment. So I actually created it and extruded it. And now I'm going to jump to the implicit modeling menu. So from this case, let's kind of take a look at it. So if we want to take a look at one of the first things that's fairly nice about the environment is it gives capabilities where I can click on an option. And keep in mind, I'm going to turn off the sketch. I am running a webinar right now, and this is all being done just on my GPU. So this makes it fairly easy to adjust things. Most of you probably who are running CAD have some type of certified GPU card. GPU allows you to kind of work off your graphics card, and it really is a much more efficient use of being able to go through this. If you want to utilize your CPU, you can, but it's optimized for GPU, which allows me to kind of change the unit cells very, very quickly here, which is very, very nice. So you kind of see a lot of different types of unit cells built into the environment. I'm going to stick with a gyroid lattice. That's going to be the one I utilize. So the first thing that's also really nice about the environment is you kind of see if I hover over each of these icons, it'll kind of tell you what each of these types mean. So this will kind of create a single fully connected surface versus a double surface. So this will actually kind of give you two surfaces. And this is kind of very efficient for heat transfer applications. So like I said, gyroid lattice, TPMS lattices are very nice for kind of building heat exchangers. So you could actually have a double surface on that regard. So if I change it to double, you kind of see what happens if it kind of makes it a two surfaces. It does actually kind of give you a little bit more geometry. Under the solid region right here, gives you a capability kind of inverting it or keeping it kind of regular. And this can be pretty advantageous maybe for a strut lattice. If you're trying to kind of create kind of a reverse cavity, you can do that, which is nice. Our coordinate system right here, because this is kind of a traditional kind of Cartesian modeled system, I can utilize it, but keep in mind, I can change my coordinate system and you'll see that it will update for the specific coordinate system I'm working in. I can also locate it if I have a local coordinate system. If I want to utilize that, I'm just going to work off of the Cartesian XYZ directions here. So our next option under the sizing option is I can actually specify whether I want something as a value of percentage. So if you start to see something that's less dense, if I type in 20%, you'll see kind of less dense material, more holes, more lattice kind of flowing through the system. Accordingly, if I kind of bump it up to 80%, you'll see much more solid material. So that's kind of how this works. You can also change it from going off a percentage to an absolute value. If you wanted to do that, I'm going to stick off of, I'm just going to have a 50% density. That's kind of a good place to start. And then our bias, if I kind of adjust this, you'll kind of see it kind of changes how it's kind of adjusting that lattice work as you're kind of working from node to node. So again, you'll see if you hover over it, kind of changing how the volumes are going to be adjusted, much like a bias in say FEM applications. So if we look at the directions right here, specifically, I can specify a uniform density. So if I go to the uniform density option right here, if I kind of adjust this, I can change it and you kind of see how it's kind of adjusting the density here, right here. So if I say, I'm going to stick with a value of 6, this is a multiplier. And keep in mind, I can also change these to be point cloud or field driven. I'm going to show an example of that in a moment. So if you're wondering, can I actually control this? I can do that. I'm not going to do that for this kind of first example, but this would be kind of our first application here. So if I hit the green check mark, you'll see that I have a lattice that's generated right here. And the cool thing is I can adjust the visualization quality if I want. I'm going to kind of keep it on the medium quality and then hit the green check mark. So one of the cool things about our tools specifically is we have capabilities to kind of adjust the geometry or go back. So there's actually a pretty cool thing within Inspire called the construction history. And if I go back to the construction history, I can actually adjust this lattice. So I'm gonna do a couple of things here. So one of the kind of useful things a lot of times is for a lot of parts, we want to actually have an interior lattice, but kind of maintain the outer surfaces. So we're kind of creating a shell. I'm going to do that in this application right here. I'm going to go to the outer body. I'm going to specify a shell. And then you'll see right here, I'm specifying a shell, and I can actually specify how thick I want it to be. In this case, I'm going to say, I'm going to apply a fillet transition and use a 1 millimeter transition. So one of the things I can do is I can then create a cross section here if I want, and grab that part and hit the green check mark, and I can see my cross section, which is very nice. So you kind of see that fillet that's being applied, which allows for a smooth transition. So that's really kind of a cool feature. You can actually specifically kind of have a shelled or interior lattice, and it's set up to be fairly easy to do that just right within the implicit modeling menu. One of the other kind of really cool things about having a construction history, so if I hit the green check mark here, is I can roll things back. So what I mean by that, if I roll this back, if you're kind of familiar with kind of traditional kind of rollback bars in traditional CAD modeling, if I want to go back and adjust the B-rep body here, so if I go back and let's just kind of create a cut extrusion on the top. So let's do that. I'm just going to create kind of just a small, easy cut extrusion. Again, if you're unfamiliar with Inspire, we can utilize parametric relations. I'm not going to do that in this case. I'm just going to kind of create a quick circle so we can visualize it. But I can dimension everything however I want. It functions like a traditional kind of explicit modeler. So if I go to geometry here, and then I go to cut extrude. So remember, these are the B-rep geometry commands. These were in Inspire prior to the 2023 release. If I hit subtract and click on that body and kind of go through and hit the green check mark, you'll see I've created a hole through the component. And then if I come up here, and if I roll things back, you'll see that obviously there's no lattice kind of going through here, which is pretty nice. I can turn off the section plane, and kind of gives me that capability if I kind of want to adjust things. So that's one of the cool things about it. I can kind of use that rollback bar and make adjustments accordingly. Let me kind of keep working through a couple different options here in the implicit modeling option. So I showed the ability you could create geometry, you can import geometry, but let's kind of get in the weeds a little bit here with some of the implicit modeling tools. So first thing I didn't show you is the primitive option right here. So if I create a primitive, these are kind of what I was talking about. Kind of gives you capabilities to kind of automate kind of a lot of basic shapes, but these can be very useful when you're kind of going through a geometry and trying to make manipulations. Keep in mind, you'll probably still be importing your geometry or maybe creating your B-rep geometry in Inspire and then creating lattice, but this is a nice way of being able to kind of create something very quickly. So I'm going to create a cuboid, and I'm going to create another cuboid. So I'm going to have two actual implicit cuboids here. And the reason why I'm going to do that is I'm actually going to combine these. So kind of just show you some options of some of the modification commands built into Inspire. So first thing I'll do is I'm going to create a, I'm going to use a different mesh here. So I'm going to, instead of using a surface mesh, which we just showed, let's do a planar mesh. And you'll see with a planar mesh, again, I think everything can be really rendered very quickly because we're taking advantage of GPU. And you kind of see as I can change these on the fly, which is pretty cool. I'm going to use a hexagon mesh. And then I'm just going to use kind of the default sizes right here. And then I'm going to hit the green check mark. And then I'm going to create another mesh, but it's going to be a little bit different. It's going to be, instead of being a hexagon mesh, I'm going to use an isogrid mesh. And then I'm going to adjust this density here. Let's go to maybe 6. 5 actually looks pretty good. I'm gonna have 5 and I'm at the green check mark. And then if I turn on both of these cuboids, you can kind of see kind of a cool shape. Just kind of illustrating what you can do. So if I actually go up to the combine option right here, I can click on both of these bodies. And you see I can kind of create kind of a custom kind of shape. I can also apply a transition where I apply a fillet if I want. I'm going to keep a sharp transition that kind of looks a little bit nicer. And if I hit the green check mark, you see right here, I actually have kind of this cool shape that I've generated. But the cool thing about this, remember, I can use this rollback bar and I'll see I have these two shapes again. So maybe I want to do a subtraction from one body and then click on the other body. And it gives you kind of a preview of what's happening, what that subtraction is going to be. So again, it functions very much similar if you've used the Boolean command in traditional CAD modeling. It's set up to be very, very familiar, even though we're working with an implicit bodies, which is very nice. Let's try another command here. Let's do an intersect command. So, and then grab the other body. I'm going to go with this guy there, and then this guy. And you kind of see an intersection, again, functioning much like kind of a Boolean command, how it functions. So it gives you some nice capabilities of kind of being able to make manipulations on the lattice front. Great. So one of the other things I want to show is I'm going to close out of this for a second here, and then I'm going to go and I'm going to generate a kind of another example. So we went through the kind of the Boolean applications right here. So maybe if I want to go through the morphing options. So if I click on the primitive option right here, and I'm going to create a cuboid, and I'm also going to create a sphere. So a lot of times with implicit modeling, it's not always, it's not always for lattice work. It can be for, other things that might be kind of traditionally difficult to do in explicit modeling. One application of that might be kind of loft creation in traditional CAD. Those who've done surface modeling, it can be somewhat time consuming to have appropriate lofts. And because everything's modeled as a kind of a single ISO surface, it makes it a lot easier to kind of manipulate things with kind of field-driven data. So I'm going to introduce this idea of a field concept within this case. So if I click on the morph option, I'm going to grab the cuboid and the sphere. So the morph option, the way it works, it's going to morph between, these two bodies we have. So if I adjust this slider all the way to be 0, it's going to be body A, and then I think 100, it's going to be body B. So you'll see the kind of the variation between the sphere and the cuboid. Now, if I go to 50%, you kind of see a mix right here, which is useful. And it's morphing between these two objects within these contexts of the body. But one of the cool things about it is I can actually create a field, which is meaning I'm going to adjust how it's going to morph between a set range of, whether it's a plane or a point. So let's actually do that now. I'm going to click on the field option right under the morph value here and select create field. So you'll see with the field option right here, it reverts to using kind of a plane. I could specify whatever plane I want. I'm going to use the Z plane. But the cool thing about it is you're going to see that it starts to adjust the morphing option as it moves between the kind of the bottom plane right here at the bottom and -50 millimeters all the way to the top. So though it's creating a really nice, efficient surface loft. And this is implicit modeling. It's not necessarily creating a lattice. If you wanted to go kind of create a lattice, maybe we'll do that. You could. You can also adjust the blend value. So if I don't want to go from 0 to 100%, maybe I want to go to like 80%, or let's make it something a little bit more drastic. Let's go like 50%. You'll see it's going to be moving much more towards body B. So it's not really having as much spherical blending. I'm going to stick with 100%, and I'm going to hit the green check mark. So I've created this kind of nice shape very quickly without having to kind of create any boundary curves or things you'd have to do in traditional CAD modeling, explicit modeling. So if I hit the green check mark, you'll see I kind of create this entity right here. And if I wanted to actually generate a lattice, I could click on this, and kind of off of that kind of cool morph shape, I can create a pretty nice lattice. I can kind of go through and adjust things accordingly, which is very, very nice. So from this application, I could save this out, but I want to jump into another application. So one of the cool things about Inspire is it's been a very prominent tool in additive, specifically structural analysis and optimization, and then also, just regular structural analysis. So a lot of the key reasons why you might be doing lattice design is you want to kind of maintain your strength and integrity while minimizing mass. Well, the implicit modeling features take advantage of being able to utilize SimSolid. So with that being said, let's take a look at an example of how we can kind of create a lattice and then actually run SimSolid to kind of visualize the results. So I'm going to close out of this file right here. I'm going to File New, and I'm going to go to File Open, and I'm going to go to this model here, and we're going to actually generate a lattice. So this is just a gas pedal, and it's something that could be conducive to additive manufacturing of metal, metal 3D printing, and we're going to have kind of a lot of solid components, but we're going to have some that are going to be lattice work right here, this kind of entity right here. So what I'll actually do is I'm going to create a lattice for this case, for this part. So I'm going to click on Convert. I'm going to turn this into a implicit body. And from there, if I want to, I can generate my lattice. So in this case, I think I'm going to use a planar lattice. So I'm going to click on planar lattice. I click on the entity, and then I'm going to use, let's use a diamond pattern. And let's type in our thickness value. So the other thing to keep in mind, we can easily change our units here because we're in the Inspire framework. If I wanted to change to IPS, I could do that. I'm going to work in SI for now, but I'll show you how we can kind of change our units on the fly. So let me just do that real quick. I can show you. Change my units, see the inches right there if I want to. So keep that in mind. That's something that's nice, being able to change your units on the fly. I'm going to use a size of 0.5 millimeters. And in this case, I'm going to specify a width of about 3. And I'm going to go in the X direction. All right, so I'm creating a lattice work right here, kind of a nice diamond lattice work. But one of the cool things about this is I can also trim these entities so it kind of has a nice union on the B-rep body. So the B-rep body is this kind of the rest of the pedal, and I have my implicit body right here, which is the lattice work. So if I actually go to the outer body option right here, click on shell, and then if I click on the trimming body right here, so if I click on it and then grab the outer body right here, it's actually going to trim it up nice. And I'm going to use a value of, I think the thickness is too thick. I'm going to go like 0.5 millimeter. And the other kind of cool thing about it is I can kind of create a transition. So it's kind of sharp right now. I might want to apply some fillets here. So I'm going to change the transition to be a nice fillet. Kind of see it starts to smooth things out. Maybe I'll adjust it, but I'm going to use a 1 millimeter fillet. All right. So from that point here, I can see my bodies. I don't need the original B-rep representation here. Like I can probably delete that. So I can right click on the B-rep of that kind of interior geometry and delete it. And now one of the cool things I can do is I've generated this lattice here, but maybe I want to run an actual structural analysis. So technically we have a B-rep body and we have an implicit body. The cool thing about SimSolid as a tool, it's a meshless based tool. So we can kind of convert everything to a triangle mesh, what you would do if you're exporting to a 3MF or an STL format. So if I actually go to the geometry menu right here, I can actually do a Boolean between a B-rep body and an implicit body. This is going to, what you'll see after it goes through this, it's actually going to create the triangles, and it'll allow me to actually set up my structural analysis fairly quickly. So it'll take maybe about a little less than a minute. And it'll depend on, because what you'll see when we actually look at this, it's creating all the triangles. So if I zoom in, you'll see all the triangles of that mesh facet data it's generating. So this would be ready if I wanted to export to 3MF or STL for 3D printing, I could do that. But what I actually want to do is I actually want to run a structural analysis here. So it's really nice if you haven't used Inspire for some of our structural analysis tools. It's set up to be a very useful, easy tool. So let's kind of think about it. These holes in place are going to be what's kind of locking it in place. So I'm going to apply some supports or some translational supports on these interior faces. So that face right there, and then also this face right here. Okay, great. I can accept that command, and I'm also going to apply a force on this, on the pedal. So let's change these units. Like I said, I was going to change the units on the fly. Let's be in IPS. Let's do like a 500-pound force value and hit the green check mark. Then if I wanted to change my materials, I could. I'm just going to use a steel material, something that I'd probably be printing this out of, and I could run my analysis. So I could hit play and actually run it. For the sake of the webinar, it actually runs fairly quick. It probably runs in like less than 2 minutes, but I'm not going to have it run. I already have one kind of queued up and ready to go. So I can actually play and animate my results. So I see, all right, that makes sense. I can actually adjust and scale things if I kind of want to visualize the things. But let's take a look at the stress values. So this is kind of the really cool thing about it. So if I change to my von Mises stress values right here, I can zoom in and I can see where some areas of the lattice are taking a little bit of the stress. So it is kind of helping with this main hole, which is being locked in place, which, as you can imagine, that's probably going to be a weak point. And this might be an application where like, oh, I'm seeing kind of a somewhat high stress here. And let me change again to IPS for our units here. It's not that high, but it might be something where if I do a call out, I can actually hover and see what that value is. So about 7,000 PSI, so 7 KSI. The steel kind of yield is like, I don't know what it is for this material. I think it's around 30 or 40. So if you wanted to have a little bit more factor of safety, what you could potentially do is maybe apply a thicker lattice in your case, or maybe do a variant, kind of a field-driven lattice, which I'm going to show an example of in a moment. But this makes it very easy for those of you who are kind of building these lattices, getting them ready for printing, being able to integrate with a nice, easy to utilize structural tool. That's you kind of harnessing the technology of SimSolid to handle that, which is nice. Okay, great. Let's jump into another example here. So I'm going to close this out. So let's go through and do another example. I think I'm going to use that same pedal, but I am going to kind of show an application where maybe I want to vary the mesh density. Like you saw that structural analysis, maybe I want to have some parts that are a little bit thicker and then some other areas which are a little bit thinner. So I'm actually going to have a combination lattice. So let me open up that file. This looks good. All right. So you kind of see I have kind of the attachment bars right here. I didn't have that on the structural analysis. I could have if I wanted, but I think I suppressed them. But I'm actually going to kind of create kind of a variant implicit modeled lattice right here. So I'm going to have two different types of lattice, and they're going to actually adjust with respect to the direction you're applying. So I'm going to actually hit convert. I'm going to click on this body right here. I'm going to make it an implicit body, changing it from a BREP body to an implicit body. And you'll see when you do that in the Inspire modeling tree right here, it will always tell you, hey, this is an implicit part. You'll also see the context menu of the visualization quality for the implicit body showing up. And I'm actually going to copy these because I want to have two different lattices. So I'm going to right-click, hit copy, then right-click, hit paste. All right, so I'm going to see I have two actual parts in this model right here. And I'm actually going to generate two different lattices because I want to actually kind of adjust how that lattice density is going to change. Okay, for clarity's sake, I'm just going to show the implicit parts here. And I'm going to go through and generate these lattices one by one. So the first lattice, I'm going to do a planar lattice. I'm going to do a hexagon lattice this time instead of a diamond lattice. And I'm going to specify a value here. I'm going to change back my units because my notes are in millimeters. Change my units here, and I'm going to go to 0.5 millimeters. And I'm going to go to a width of 5. Does that look right? Yep. And I'm going to go to the X direction. Okay, so it's fairly similar, except instead of using a diamond, I just wanted to use a hexagon here. Okay, great. And so we'll see we have this body right here, this implicit body of that lattice I generated. Now, if I want to go to my other implicit body, because again, I want to kind of adjust the density, I'm going to do that now. So I'm going to create a strut lattice here. So I'm actually going to click on the strut lattice option, and I'm going to use, I think, a body-centered cubic lattice here. and I'm going to specify a size of 2 millimeters. I think that's based on the size of this part. Yeah, that's pretty good. And a width of 5. So you can kind of see it's much thicker. I'm adding a little bit of thicker density right here on the strut lattice. This is kind of what I talked about, where you might want to have a more dense lattice in certain areas. And I'm actually going to combine these parts. But instead of using a combine command, I'm going to use that morph command, which I showed you earlier, which is also pretty cool. I can morph to implicit bodies. All right, so I'm going to hit the green check mark. I'll see right here I have the 2 bodies. If I turn them on, okay, it's not quite what I really want because it's kind of just interfering bodies. I actually kind of want to have a transition from one lattice to the other. So if I actually click on morph and I grab both of these implicit bodies, and then I can actually create a field data to actually, I want it to kind of morph with respect to a specific direction. In this case, I'm going to say, I want it to move in respect through thickness, which is, I think, the X plane. Yep, the X axis. So I'm actually going to create another field value. So a field value, remember, it's just how you're, affecting density with respect to a constraint. In this case, it's going to be driven by a plane. So let's go and create a field. And you kind of see I can change a lot of directions, but I want to use actually instead of the Z direction, I want to use the X direction here. And that's perfect. So I see I have the strut from the one side and I'm kind of varying it out to the other lattice. So it's a little bit thicker on the one side and blending between the two. So if I hit the green check mark, you'll see that I've generated this thicker side lattice. So if I show the whole part now, let me just show the whole part. And I just want to hide that one BREP body where I generated the implicit body. This is a quick way of being able to really visualize how you can adjust density of material, which is really, really kind of cool. I mean, that's just a quick application of it, but just shows you how quick you can kind of combine and adjust lattices with field-driven data. So the other thing that's fairly nice about Inspire is there's a lot of kind of control and creation options within kind of the given GUI of the surface, the planar, and the strut. And like I mentioned in the next release, stochastic latticing. But if you actually wanted to kind of create your own kind of custom implicit body, you could do that, because remember, implicit modeling is based around an ISO surface, and it's really kind of set up to be very useful or easy to kind of automate certain commands. Everything within Inspire has always, up to this point, been allowed us to kind of update the Python API. The same thing can be said for implicit modeling. So you'll see right under the actual kind of tutorials option, this isn't a Python scripting class, but you can kind of see on the implicit option, it gives you a number of all the different commands and the language on the different lines within Python in terms of that you need to be aware of. It gives you those kind of capabilities of spheres, cuboids, etc., surface lattice, the different options you need to have. So let me just run a couple of Python scripts so you can visualize it. So if I go under my view menu and hit Python window, so I just need to bring in my actual Python script right here. So I'm going to do that. I have a couple I'll run real quick. So let's do that. All right. So let's run this first script. I'm just going to bring up the actual script so you can see it real quick. All right, so you see this first script right here. I can do a copy and paste if I want, bring it right into the Python command line and then hit enter. And you'll see it created kind of a heart-shaped lattice, which is pretty cool. And you can kind of see all the commands going through that. It's telling you the different bodies, which is nice. The other thing that's pretty cool, like we mentioned, is implicit modeling is very useful, not just for lattice work, but for applications that might be more labor intensive in traditional BREP modeling. One thing I can think about would be modeling gears. Specifically, if you have a lot of gears in a system, as you know, if like helical gears or coil gears, it can be somewhat labor intensive, not necessarily labor intensive, graphically exhaustive if you have like 20 different gears in a system. And you can just write a real quick script in Python and kind of create a gear. So let's do that. I have another one here, just a helical gear. So let me just open it up. You'll see right here, it's creating an implicit body of the gear. I'm gonna paste it in my Python window, hit enter, and you see it creates a perfect gear. And it's very easy now. If I wanted to apply a lattice, I could. On my actual gear, I can change the coordinate system now to be cylindrical and kind of see you have a cylindrical lattice. So there's some cool things you can do in the Python scripting. Definitely the tip of the iceberg here, but I wanted to kind of bring it up accordingly. Okay. The final thing I'll say right here, as far as being able to export out, if you wanted to export out, you can very easily do that. Kind of see that 3MF format, as well as if you wanted to kind of go to STL or an OBJ format, you could do that as well. So let me jump back to my PowerPoint here. Oops, let me reverse this. I'm going to kind of open it up to questions right now. The one thing I would say is keep an eye out on our YouTube page and our blog. I actually went through a kind of a basic tutorial a few weeks ago when, end of December, going through how to build your own lattice. So check that out on the blog if you want to kind of create your own lattice and Inspire. Definitely keep an eye out on our socials as well, as we are continuously updating them. And I think, as always, this recording of this webinar will be posted on our TrueInsight YouTube channel.